Hello, welcome to Industrial Plant class. Today I also trying to continue the last analysis. Today is not about coronavirus. We continue the analysis of the laboratory, and I will start to Python lab platform. Load. So what I'm gonna do today is that we actually parsed out shared DNA component, so very short sequence that is conserved in promoter region. So I will retrieve the sequences to count the conserved sequences in Arabidopsis also, because last time I was trying to see what was that? I was trying to see the correlation of expression of pair of gene that is connected by shared trans element. So, but the problem was that we don't have enough information in a laboratory genome. Laboratory expression. So I want to use the Arabidopsis information rather than laboratory information. So I will retrieve the conserved sequence and count the sequences in the upstream of Arabidopsis. So that's the thing I want to do today. Okay. Right. So I will open up laboratory genome analysis. And what we have was that laboratory promoter block table. And this was the conserved sequence. Is it right? Yes, they are all the conserved sequences. So I will open up new Python. Conserved sequences. And import pandas and data frame. What was that? What was that? So these sequences are all the conserved block. So I will retrieve regardless query ID. Okay, so this is the BIOS. So I don't want to use any index. So I will, let's say, I will make block list in BIOS and this gonna be list again. So I will block list. I will just, let's say, append the list in the block list. If you set this thing, then the redundancy will gone forever. Okay. But the problem is the blank, right? So there is blank. So I want to remove the blank strip. So this is the reason why we have to learn how to code to solve this small problem. So how many blocks we have? Length. So this many blocks we have. Maybe this is too much, I think. So I want to count it. I want to count. Input. Making data frame for the blocks. Block count. I need to transpose the data. Let me wait. The reason why I'm counting these blocks, I want to retrieve very important blocks, not the blocks that occur just one time in whole analysis. So I will calculate the occurrence histogram using the. So we have using the database data frame. So we have count. So this sequence occurred only one time, right? We have a problem. So I want to make it all uppercase. Okay, I will make it all uppercase. UPP. Yeah. Because computer distinguish small letter and upper letter, so capital letter and lowercase letter. So if you put upper here, so upper function here, then your sequences become all capital letter, not lowercase. So even though the sequence is the same, if the letters are different in a way you express, like a lowercase or uppercase, then computer recognize it as different, not same. So I want to have the lowercase or uppercase has no effect on our calculation. So descriptive statistics. Okay, then we can make a histogram to see the situation. Nothing happened because we didn't put the explicit command that we will see the pictures inline of this notebook. So I will increase number of bins 50. Okay, so I want to make, so you can see the blocks shape and blocks count rather than what I want to put it 50. Then how many? So we have 500 blocks. So I want to make this block as our selected block. Okay. So you can observe many variations of tata, and the other ones. So I want to use this. So maybe this can be kind of profile of our analysis. So we just say that these are just tata, but you can see there is so many variation. So this must be similar part. This must be very similar part. But that is okay to see the situation. And genome is what I'm thinking. So 2 CSV and blocks selected SV or saved, and I save. And let's download the Arabidopsis genome from Arabidopsis site. Here you can download the file, maybe FTP archive, from the FTP archive. Nowadays this is really slow. So plant genome EMBL ensemble plants. Maybe we can download FTP archive that I want to open it. 뿅. What? 그 주소 복사. So tear as FTP drive, and I think we can retrieve sequences. Oh, I think this is so complicated. maybe we can download from this site, Arabdopsis Italiana. Then we can use Ter 10, right? Ter 10. So let me use just Ter 10. Okay. So download DNA sequences, genome assembly. Downloads. Okay, this is better. Arabdopsis Italiana in go. Sorry. Arabdopsis Italiana and this must be the genome, right? This must be the genome. What? Okay. So Ter 10 we have. So top level. 링크 주소 복사. We copy the link and download. And let's download. So we can download using wget, right? So let's download it. I want to make a new file. Arabdopsis upstream logs. And I want to download GFF3. All right. GFF3. No. So GFF3. Click and find. Okay. So we could download the files. So what do we have? Here? So we have pasta. So so this is conzipped. So compressed file. So I want to open it up using conzip Python. Conzip open. Yes. Conzip open. Import conzip open. Arabdopsis. Right. File equal Valid. I think this must be similar with just open. So part. Sorry. So we are reading all bulky file, even though that is compressed. And what do we have? Sequences. Bulk, split, and so I think I already explained a lot of this pasta reading trick. This should be this one, and now we have the name of sequence. Sequence should be joined split. Okay. So dictionary pasta. Name sequence. So what is the problem? Byte-like object is required. Then I will check what we have in bulk. So this byte to string, convert byte to string, byte. So this is the way. So this one, so if this, it looks like a string, but if this string start with B, which means this is not just string, this is byte. So what is the byte? Byte Python. What is byte in Python? Byte string in Python. So what is the difference between a string and byte? What is the difference between a string and a byte string? So one guy is saying that assuming Python 3 that you are using, a string is a sequence of the character. I don't know what it is. These are an abstracted concept and can be directly stored on disk. A byte string is a sequence of a byte, things that can be stored on disk. Where's the meaning? So I think this is the explanation that Python actually using the string that cannot be directly stored on the disk because it used like a Python-like string. But if you want to save this string into disk, then you have to change the string into byte. It looks like, right? So the byte string is that byte that can be stored on the disk, but the normal string that we are using is not that byte that can be stored on the disk. So like it must be kind of the interpreter like a Python can use form. I don't think that is so important. But what we have to know is the way we can change the byte into the string, the normal string that Python can understand. So yeah, so that is the problem. So Python string can have many methods, which can be split, right? But byte have nothing, it looks like. Okay, so we have a dictionary. So we have a dictionary and we have dictionary. What? What is the problem? So let me check the bulk again. Bulk. Oh. Okay, now we have it. And I don't want to have this unnecessary information. So this DNA is chromosome, or this DNA is coupled, or and so on. So I don't need it. So I will remove split. Zero. Okay. Then okay, now we have it like this. Okay, so I merge everything like this. Oh. Okay, and we have what we have. What pandas. So we have pandas data frame. Now I'm making data frame for the GFF. So we have a GFF for the Arabidopsis. GFF is quite easy. Sorry. No. Separation is step. Command shop header none. This is the way we can call the GFF file using pandas. Then we have this information, and what we need is that, so we will retrieve the first position of the gene, right? So what I'm thinking is that we will select 2 and CDS, mask it, and GFF M. Okay, and we will label the transcript. We'll label the transcript with regard to the name, the parent name. Okay, so I load my code Kang. So there is no. Okay, there is no Kang. So then I will show you the way I'm doing. And 5. So this is the way. This is the information of first one, and I will retrieve the parent. Okay, so I will retrieve parent. So, but you can observe this information is separated by this semicolon, right? Semicolon can be split in this way, right? And you can split them using this command, and you can make them into dictionary in this way, right? Oh, so this is how I'm doing. This is how I'm doing. Okay. So I will make a definition. I will make the info parse I. Maybe I can make it I and return this dictionary and this information is I, right? So this one will be CDS, and I will select the information by apply. So each information will become X by lambda, and import par X. Then it will return dictionary. So this will become dictionary. So I will select the parent, but I don't need this transcript. So I will replace the transcript. Transcript. 뿅뿅. Okay. Yay. So I will name this information as the transcript. Good. Okay. Then you have transcript name. 그죠? 그렇습니다. So if you consider this trend problem, you have to consider this trend information, because the upstream sequence of the gene will be differ if this one become minus, right? So anyway, okay. So I will index this guy. So if you select this one, the first one, the very first one, will be like this. It will be like this. So this is the first trend, so there is no problem. So I will select the first one, right? So the first one. So this is the first one. So just value. The first one is start point, start base, no position. Start base position we can get. So we can design the function get start base pos x. So return this one, right? So transcript. No. So it is not that difficult. So no. So this is the starting position, but no. If I will grab this one like this, and so I usually use EDF naming each data frame. That I usually name it in this way. in the strand. So if the strand bios plus, that it will be like this, else then return. So let me check what do we have. So let me check. Minus. Okay. So this guy have different scheme, right? So this is minus strand. So this end here. This ends here. So for values, the last one is the starting point. But you have to return it. So return. So I mean true and false. Let's make this in this way. Minus and okay. Minus 1 and 4. Okay. So let me do this again. If we see same, okay. Okay. So we have very good function here. So for data frame entrance index and let me put set there and see the length. So many stuff, but what I want to do is I want to remove the transcript information. So sometimes it is very important to have the transcript information, but here I don't want to have it. So in list, maybe it will become like 30,000 or 2,000. Okay, 20,000, 27,000 genes are present in Arabidopsis thaliana. So for each gene. List. That's all. So our limit is for test. Get start base position, gene, then strand, and starting start force. Right? So I will force the gene into first transcript name. Sometimes the I want to print it, the gene name. Sometimes the gene just have one CDS, So let me check the this only have just one CDS, so I have to change this I say the function. So if you shape it, then the length is 1. So if the length of shape 1보다 크면 no, you don't need to have this one because it will be the only one string. Right. Let's see. Okay, there is no error. Okay, then maybe we can retry. Okay, so we have to return one more step. We will return chromosome information also. So we have to. This chromosome information is not that change with regard to the strand information. Right? Okay, now we have chromosome information also. And we can retrieve the sequence. Dictionary. We have dictionary. We can map the sequence by chromosome and the start post plus window. So what do you want to size? No. This is not window. Upstream size. Upstream size will be what? Just 1K. I want to use just 1K. Good. And sequence, we can retrieve the sequence. Right? Print seq. Okay. So why do we have no 5? Dictionary pasta keys. We have 5. So we have to change this into string. So upstream. Okay. We can retry. Good. So let me. Seriously, I want to remove useless stops. This is the way we parse. So definition should go up. Definition go up. Okay. This one and this one and this one should be merged. Let's align these guys 이 됐죠? Yes. Satisfied. And I will remove this test stops. Okay. And let me retrieve the data frame of blocks. Block selected, right? So we have blocks. So we have blocks. And the unnamed. Unnamed. So let's consider these guys, these sequences are our what? Features. So we have features now. And for sick. So let me show you. So we have a sequence and we can just count it. Count in this way. Okay. We have how many? So we don't have this one. So, C count feature. So I want to open up new data frame. Feature to count. So that is empty. So I told you that in this way it will become very slow, but I don't care. So no. Gene and feature and count is our goal. Okay, so how it will be in this way. In this way, we will have the profile. So let me show you the C1 SSB, the result in easy manner. So C1, I think it will show us the profile, right? So it has profile. It has profile in this way. So most of them has nothing, but some of them has the profile. So let's continue using everything. So I will not print, but I want to see the speed of the analysis. The speed will be very slow, I can guess. TQDM. Then maybe we will wait for a while. So we will take like a 30 minutes. So I will see you again after 30 minutes. Sometimes it will take 1 hour. I don't care. So see you again. Okay, the calculation is done. So let me check. Oops. Something goes wrong. Something goes wrong. So the reason why this goes wrong, I changed a bit. The gene list, I use the gene list, but I changed the transcript list because sometimes, even though I add the .1, there's no transcript names in such a way. So I just grab the actual transcript name using this command and iterate using this transcript list. So I didn't change this transcript into, I didn't change gene into transcript before, so this become in this way. So I run it again. Okay, finally we have the data frame. We have data frame with shape is like this, right? So we have almost 500 features, and our gene number is 27,000. So it took a lot of time. So I saved this data frame to CSV. Okay. Okay. So let's check how we have the data. So hopefully we will get some picture from this class method. Sorry. It takes a lot of time. Let's wait a few minutes and hopefully we will get the